Okay, so now we're going to go on to part 2. Figured out for part 1 that the initial pH of the buffer is 3.35. That's if we have weak acid, HNO2, and some salt, NaNO2, that are both at 1 molar, a solution of that. Now the question is, what if we add some acid? We add 0.05 moles of HCl. So let's think about the fact that HCl, hydrochloric acid, when I find my paper, that is a strong acid, right? So that's going to fully dissociate. The way that buffers work is when you add acid or you add base, the pH should not change very much. So we're going to check on that as we add this little bit of acid here. All right, so let's first consider the dissociation reaction for hydrochloric acid. So this is dissociation. And we have HCl that is dissociating fully in water to form H plus and chlorine minus. So when we write the ice table, we know that we're starting with 0.05 molar HCl, and we have no protons or anion. The change is that, like I said, we fully dissociate, so that means all of this is going away and showing up over here, just like with the salt, so that our equilibrium concentration is 0, 0.05, and 0.05. Okay, good. So now, this concentration, this is H plus that's added to the buffer system. This is what we are considering. Okay, so the next piece is then this reaction, the acid reaction with the conjugate base. So let me just write that down. Acid reaction with conjugate base. So this conversation gets us to remember back when we did, when we talked about key concepts that we needed to know. We need to remember that for this, we have H plus that's reacting with NO2 to then form NO2. Why is this? What's happening? So remember, we have some protons that are formed here, right? We're going to take those protons, we're adding it. We're also adding to the anions that are formed from the salt, from the strong electrolyte that fully dissociated, that is here. And then that is going to combine to form an acid. So we are going to consider those concentrations. So initially, we start with 0.05 concentration of protons, which came from here. We start with 0.1 molar NO2, which came from back before this conjugate base that dissociated, and from the salt. And then we start with 0.1 molar of the weak acid. Why is that? Because here's 0.1 that's up here that we're starting with. All right, change. What happens is all of this acid that's added reacts with the conjugate base. How do we know that? This is my heading. Acid gets reacts fully with the conjugate base. That's what's happening. And it is fully consumed. That's actually our limiting reactant, if we go back to limiting reactant. So that means that all of the acid gets dissociated. it gets consumed. And that means that this is our x. So our minus x over here is 0.05. And then we have plus x, which is 0.05 over here. All right. Next, equilibrium. So we add these up. There's now no more acid because it is fully consumed by the conjugate base that was present from the salt that was added to the buffer. We subtract this, and we get 0.05 as our equilibrium concentration of conjugate base. And then we add these together to get our concentration of our weak acid, which is 0.15. So now we know that for our NO2, this is our conjugate base, and this is our acid. Let's go back to the Henderson-Hasselbalch equation. No, you can't wait. I can't either. So let's go ahead and do that. pH is equal to pKa plus log of conjugate base, which is NO2 minus, over acid. Now, we're trying to find the pH if we add some hydrochloric acid to the system. We have everything that we need in order to figure out our pH. We have the pKa, that's from before, that's 3.35. Let's write that in. This came from before, from the problem before, the video before, okay? Just reminded everybody. Plus log of our concentration of our conjugate base, there it is, 0.05 over the concentration of the acid, there that is, 0.15. So now all we have to do is plug in these numbers to figure out what the pH is. Once we do that, we end up calculating that the pH is 2.87. And that's our answer for part A. Now, does it make sense? It should, because we end up adding some acid. If we add acid, that means that the pH should decrease. We started with a pH of 3.35. We added a little bit of acid, and indeed, it did decrease. Not by a whole lot, but a little bit. And so, that's how the buffer works. So great. All right, next part is part 2.